ठीक है.
Good morning, Colombia. I am Ripon Patgiri. My presentation topic is impact of metadata server on a large scale file system. My content is these are the contents, and I would like to present this in this video. So big data. Big data is the most popular buzzword in IT industry and business world, and most of the organization, government organization, private organization, it is most hard word. So big data can be defined using three V's. Three V's. One is volume, velocity, and variety. Volume means size of the data, velocity means speed of the data, and variety means that diversity of data, diverse data. So volume is big data is growing a huge volume of data with high speed, that is high velocity, with a variety of data. So this is big data. So big data is the most popular paradigm, consists of huge set of data. That data and big data, it doesn't have any difference, but only the difference is that its size is high and growing speed is very high, and it consists of variety of data, maybe structured, maybe unstructured, or maybe semi-structured data. So these are the big data. Storage is built using block store, file system, object store, or maybe hybrid of these systems. So metadata is large in big data system. So metadata size, if we imagine that what is the metadata size may be 1 GB, but 1 GB is too small. However, for metadata and in the RAM, if we relate it, metadata and RAM, then it is too high and too large for that, because it associates with data. Without metadata, data doesn't exist. Say for example, soul is the metadata and body is the data. So without that soul, body doesn't exist. So the metadata size is large. Therefore, a standalone MDS cannot hold entire metadata of the storage system. So there is huge explosion of big data. So due to emerging technology, probably everybody is using mobile phones, laptops, tablets, computers. Everybody is directly or indirectly contributing towards the big data. Everybody is generating data every day. So data size is growing rapidly, thus conventional system doesn't work at that time. So however, the modern file system scalability become questionable due to insufficient memory space in metadata server. So we'll discuss it later, because this one will come into later. So next. So IDC report, big data analytics revenue will reach $203 billion. That is huge, as IDC predicted, and it is 2020. So, and Peter quotes that information is the oil of 21st century. So data monetization is the key source of success of any IT organization nowadays. So Forbes quote that 2025 there would be 180 zettabytes of data. That means everybody has to face the data size of say for example more than exabytes. Now Google is facing the 15 exabytes of data. and NSA is facing 10 exabytes of data. It looks like a huge monster for nowadays, but in a short period of time, in 2025, we have to face this problem. We have to deal in this short amount of time. So, this short amount of time, we have to do something so that we can able to handle this monster size of data, and it will create huge problem with storage system, as predicted by Forbes, and its revenue will be 180 trillion. This is its size is 180 trillion gigabytes as compared to zettabytes. So next slide. So metadata server defines the scalability. This is something new. So because metadata server defines the scalability, for example, let us take an example. Hadoop, everybody knows about the Hadoop distributed file system. So Hadoop distributed file system has name node, that is known as master node. In Google file system, it is known as master node. So they have a single metadata server, and that metadata server cannot handle that traffic of that incoming metadata request. Maybe read operation, maybe write operation, maybe update operation, maybe delete operation. This is in use and it becomes bottleneck. So, and scalability, and if it increase the size, metadata size, it cannot handle the metadata size. So standalone MDS has limited memory space. So we all know that standalone system has limited memory space, and therefore there is a new requirement of that modern metadata server. Next. So this is the pictorial description of metadata server and client and data server. So this is data server, and this is metadata server, and this is client. Client will request to that metadata server. Client doesn't know where data is stored, and metadata server will request the location of that exact location of the data server to this, and it return the request to this master or name node or metadata server, and it return back to the client. Now client can exchange or communicate the data directly through this channel. So interestingly, there are very few practical implementation of clustered MDS. So what is clustered MDS? Actually, clustered MDS is a set of MDS to perform a metadata service. It is a set of server. It is dedicated set of server, and this is at most 64 TB data can be accommodated in 16 GB RAM of standalone MDS, where block size is n equal to 512. This is a good example. If a small file problem, Hadoop distributed file system suffers from small file problem. Let us take the example of a small file problem. A small file problem is, say for example, this is 16 GB RAM. Standalone MDS has 16 GB RAM and data size as 16 GB. Now that entire data consumes entire RAM of that metadata server. Now problem will occur serving only 16 GB data or 16 MB data, not more than that. Then that is small file problem. So it has been addressed it has been addressed, but the problem occurs is if this size grows tremendously, as Forbes quoted that data size will grow 180 zettabytes of data. That means we have to think twice about the metadata server, how to deploy the metadata server. Next. So, effect of Bloom filter in MDS. Let us go through the effect of Bloom filter in metadata server. A Bloom filter is introduced in 1970 by Howard Burton Bloom. So, Bloom filter is a probabilistic data structure with yes or no. This is hashing system. This is hashing system. It introduced that yes or no with an error tolerance of false positive, false negative. It may contain false positive or it may contain false negative. So here, say for example, this set is Bloom filter is S. S is a set. So we would like to search a key K. Then if K is inside the database, but Bloom filter returning that K is not exist in the database. So it will be false positive. And false negative, if K is not in the database, K is in the database but showing not in the database, it is false negative. Next. So false positive and false negative is the overhead of a system. So if we introduce a metadata server, with Bloom filter, then it has an overhead of false positive and false negative. So we have to think about that false positive and false negative. But the advantage is that if we use hash or tree base, that it takes huge memory space. That means in metadata context, if we say that, so for example, if we say 1 GB of metadata, it means it is too large metadata. So 1 GB of metadata require in the hash 1 GB of another RAM space. So therefore, in Bloom filter, if 1 GB of metadata requires few KB of memory space. Maybe 500 KB will be enough for accommodating this 1 GB of or 2 GB of metadata. So next. So this is effect of MDS on file system. So as we have seen that, as we have discussed that a Hadoop distributed file system suffers scalability for name-node, because name-node is standalone, because huge request of metadata operations will come and then has to respond. So this become bottleneck, and even in worst case it become hang if the request size is very large. So there is no solution for scalability or bottleneck. So the clustered MDS is the another option. This is a high scalability of large file system. Cluster, if we deploy in a file system, in a large file system, then it is a better option. So besides, some clustered MDS offers infinite scalability metadata, for instance, Dr. Hadoop, and thus metadata scalability of a file system is directly related to the MDS, because metadata server defines how to retrieve a data from a storage system. It defines the rule and it defines the scalability. So clustered MDS provide a load balance, because it is distributed among the clustered metadata server, and there are very less loaded, and even if we can distribute the load evenly, then it is become lightly loaded. And clustered MDS enhance the response time because of low load. So losing metadata cause data loss, because without metadata there is no meaning of data. It becomes garbage. So metadata is the soul of the data system. Any kind of data system, it coheres with the data. So if suppose, for example, Hadoop distributed file system or Google file system or QFS or any other file system who applies that standalone file system or who depends on the standalone file system, then if that metadata server down, that means, or permanently crash, that means data are gone. No, there is no method to retrieve the data. So therefore, clustered MDS ensures that data reliability, even network failure or system crashes, because it is distributed and replicated among the servers. So these are the trade-off for who designs that metadata servers, because we are reaching 2025 very shortly, because we have to think about how to handle all those monster size of data. So this is trade-off, means that we have to sacrifice to gain one thing. We cannot get both at one time. Say for example, performance and consistency. Either we have to sacrifice the performance or we have to sacrifice the consistency. Here, cache performance and load balancing. Either we have to sacrifice performance to gain load balance, better load balance, or sacrifice load balancing to gain cache performance. And write intensive and read intensive. If we make write intensive metadata server, then read intensive will be slower. If we make read intensive metadata server, then write intensive will be slower. We have to sacrifice one, or we cannot get both at one time. And network access and bottleneck. Either we have to sacrifice network access or bottleneck. If we allow bottleneck, then there is no network access. If we sacrifice bottleneck, then there will be network access, because there is distributed in the system. So we have to synchronize the system among all the MDSs. MDSs means metadata server. So this is the key outline comparison chart of metadata server till now it presents as per our investigation. So this is name, scalability, hot standby, load balancing, cache performance, latency, and number of RPC, hotspot issue, hiccup, write throughput, read throughput. So, for example, let us compare HDFS and Dr. Hadoop. For example, let us compare HDFS and Dr. Hadoop. HDFS is support standalone MDS, and Dr. Hadoop based on clustered MDS. So here scalability is limited, because as we have described that scalability cannot be increased because this is single system, and in Dr. Hadoop it is infinitely available, because we can increase the number of nodes. And hot standby, once metadata server fails, single system, then no replacement. Manually restart, or some sort of things has to be done by the administrator. Here, Dr. Hadoop, it is hot standby facility is there because it is replicated, the metadata is replicated. Next, here load balancing. Load balancing is obviously negligible in, not applicable in HDFS because a single system there is no load balance requirement, but Dr. Hadoop requires load balancing. And this cache performance, obviously that a single system has a good cache performance than a distributed system. And next, latency. Latency is no requirement of latency because there is no synchronization among metadata server in HDFS, but Dr. Hadoop requires. Now, number of RPC, Hadoop distributed file system doesn't require any number of RPC because they did not have any communication between any kind of server. Now, Dr. Hadoop requires that number of communication between each server. Hotspot issue. Hotspot issue because it's a hotspot issue means suppose once a Colombian film is become hit, so it is searched again and again by entire people, by entire world. So this movie is become hotspot. So this metadata, this data has to be served by single system in the HDFS, whereas Dr. Hadoop it balance with that other metadata server. There is no loop. So hiccup problem. If HDFS metadata server is down, that means there is infinite time of downtime. Maybe, for example, say administrator has to come and restart it again or replace the machine again, then only it will work. In Dr. Hadoop, it does automatically because there is a replicator and automatically take over the charges. And write throughput is very good in Hadoop distributed file system, and Dr. Hadoop it is not so good because it is distributed among the server and throughput is very less as compared to Hadoop distributed file system, similar to read throughput. Next, continuing the same tables. So same comparison. Single point of failure. This is what we are discussing, that single point of failure. Single point of failure is that Hadoop distributed file system has single point of failure. That means once metadata server down, that means everything is down. So Dr. Hadoop it doesn't have single point of failure. And high availability, HDFS, Dr. Hadoop and HDFS, we are just comparing it as an example. HDFS, it depends on God. It really depends on God. Whether that machine is running or not. If down, then entire system is down. It is not available. For the administrator has to replace. In this case, Dr. Hadoop, it doesn't require administrator because it is replicated. And renaming overhead, Hadoop distributed file system has non-renaming overhead because it is constant. And Dr. Hadoop has renaming overhead because it has to synchronize among the distributed file system, distributed metadata servers. And communication cost. This is communication cost. So communication cost in HDFS there is no communication cost, and in Dr. Hadoop there is communication cost. Obviously there is communication among that MDS. So uptime depends on both in the Hadoop distributed file system, and Dr. Hadoop it doesn't depend on that thing for both. So POSIX compliant, only POSIX compliant is that here Kelvin FS and batch FS is the POSIX compliant, and however only one MDS has found that Kelvin FS has provided the J-over facility. So these are the key issues as we have investigated, that we have found these key issues, that scalability issues, load balancing issues, fault standby issues, synchronization issues, throughput issues, cache performance, fault tolerance, and consistency issues. So these are the issues as we have discussed in this slide, in this presentation. These are the issues to take care of when we design the metadata server. Next. So this is coming to the conclusion. Reducing the number of network access is the prime challenge. Next challenge is that reducing the synchronization cost in distributed or clustered MDS metadata server. It is very hard to adjust among all MDS dynamically. Readjustment cost is required. So data doesn't exist without metadata, as I have emphasizing that data without metadata, data doesn't exist. So in addition, MDS has limitation of scalability on the file system, and also MDS defines the retrieval process of data, because it is the main theme of this presentation, because MDS define everything about that, everything about the file system, how the file system will behave. That means metadata will define how the file system will behave. So these are the references. Next, these are the references, selected references, and thank you Colombia.